Well, let me introduce myself. It's right, I'm quite old and quite long in the business, more than 20 years actually, and we started inventing quality assurance systems for wood pellets about 15, 20 years ago in Austria, where the business started. Of course, to start in a completely new business is a very tough one. So over the last 20 years, many things changed. We've built up some experience. We are currently doing EN Plus and DIN Plus audits in more than 80 plants worldwide. Some years ago, we also developed new European and then finally international standards for the test equipment. And at that time, the systems were not available on the market. So nobody supplied testing instruments. So we built them in our research institute ourselves, and we were actually asked by companies to provide these systems because they couldn't buy it. So we started to build lab instruments. And that was some years ago, and that's now our main business. So, as I already said, we do EN Plus and DIN Plus audits. We have an accredited laboratory for fuels, and we supply equipment to pellet plants and also to laboratories. For example, this is our durability tester. It's now used in more than 200 plants worldwide. We have it in all continents. You see Spain is quite little, just three of these systems, some more, so we are not very well known. So this is a chance that we become more well known here. We talk about quality control in pellet production 4.0. Let's start with 1.0. When you start pellet production, what do you need? You need a pellet press, you need raw material. To fill in the raw material on the pellet press, you at least have to know the moisture content. Otherwise, it doesn't work. You will not get pellets. I mean, we know that there is still a lot of pellet plants worldwide which just have the moisture content and the pellet press. We have here two systems, like the one on the left-hand side, that's from far away from Malaysia. They don't even have a dryer. They dry the raw material outside and just wait. And when it's ready, they fill it into the press. Or on the right-hand side, that's like in East Europe, they have a very simple 20 euro moisture meter to measure the moisture, and then they fill it on the press. Does that work? I mean, in principle, it does not work. You cannot get a stable production. You will have a very low availability of the plant. You will get no certification. There is different requirements. You will need a lot of power. You will need a lot of wear. You need, all the dies, they will break immediately and all these things. So finally, these small and not automized productions will fail commercially. Here, that's from the last two pictures. You've seen the raw material. That's now the pellet plant inside here on the left-hand side. You see two people standing on the equipment, so they just shovel the material on the press. That's it, basically. That's a pellet plant, making 20,000 tons. Well, doesn't work. I mean, not commercially. And on the right-hand side, and you know that's a control system of a pellet plant in East Europe. That's also. I mean, these systems are there. Let's go a little bit ahead. Just look what we see with 2.0. I mean, pellet plants then recognize doesn't work, so the customers complain, it's too much fines, the pellets break, so they invest in laboratory equipment. Very often laboratory equipment is too expensive, so they build themselves systems. They measure the fines, they measure like the bulk density. That's a nice one actually, 2 cooking pots welded together. I mean, in principle it works, but the results what they measure were wrong. It's not suitable for any kind of control of the pellet plant, and you cannot stabilize any production. And of course you cannot get a certification, EN Plus, with these instruments because they are not according to the standard. So, I mean, at least people try, but it's not much better than 1.0. The next step is you have a quality control like we require now for EN Plus and for DIN Plus. That's probably the majority here in Spain. As you see, we are not at 4.0 yet. It's still 3.0. It's the minimum. What does it mean? It means that the production control, you measure the fines, the oversizes, the bulk density, the water content, the durability. It sounds a lot, it's not. You do the sampling once a shift. That's not a lot. It is sufficient to get certification, at least like it's the base level. Even if the results may be sometimes wrong, because nobody really checks, you do it sometimes. Usually there is no real calibration or validation of the results. So you measure something, you report it, the auditor comes once a year and says you're doing the job, everything is fine. I'm not sure if all the customers will be satisfied, but anyhow, it works. Even if the results are sometimes wrong, it doesn't influence because you do not use the values usually to control the pellet plant. So why do you do the job? Just to get the certification, basically. When we go a little bit further, I call it 3.5. It's more than is required, for example, for EN+. You increase the frequency of testing. So you do it quite often. So you really look what's coming out of your pellet plant. You make additional parameters. Like, for example, if you produce industrial pellets, you have to measure the ash content because that's in the contract. Yeah? So it's more than is required in EN+. You also start to invent online measurements in the pellet plant. Like, for example, moisture control. We've heard in the morning, if you have an online moisture control of a dryer, input, output, you start controlling the dryer. You start influencing the process. You make it more efficient. That's a good way, actually. And that's where most of the leading companies in Europe are at the moment. So they do more than is required. They start having additional online sensors on some equipment. But is this the end of the line? Well, I don't think so. I don't think so. Because we have still a lot of challenges. First of all, the reproducibility of the test methods is often limited. So, for example, if you measure the bulk density for 3 different persons, you will get 3 different results. What does it mean? It's useless. You have a high influence of staff, and that's very important, actually. The staff influences the test results just by doing the tests themselves. But that's not the most critical one. The analysis itself may be, the staff working in a production is very often not very skilled, so they do the test because they were told to do the test. They do something, but they don't understand why. And that's why they don't know if it's important or not. They sometimes do mistakes because it's just boring, doing every day, every shift, every hour the same test, so they do whatever and write any numbers. Especially in the night shifts, that's people who operate plants know that the stuff in the night shift is not very motivated. So what they do is they write in everything. Nobody cares. There is no boss. So you just sit there and just write the values from the last test, and finally it works, it's there. But it's not a quality control. And the problem is sometimes when you're in a night shift and the quality is not fine, and you report that, you will be blamed in the morning from the boss. So if you write down it's fine, and it goes to the big silo, nobody cares, and you're fine. So the staff is a big problem. There is even more, yeah? And of course there is limited staff. In some plants in Europe, we have just 2 or 3 people running a plant. If there is a problem in the plant, it doesn't run. So people are out and try to fix it. Nobody is taking care about the quality assurance. So there is a couple of things going on. And one thing is that if there is a non-compliance, especially for industrial products, you may get a problem with the buyer. And I don't have to mention what it means if you have a 4,000 or 10,000 ton vessel going to a customer and he says, no, it's not complying, it's a big damage. So maybe it's interesting to go a little bit further. Now I come back to the 4.0. If you use automatic analysis, you reduce the human influence. We have heard that already before. That's a very important thing. You reduce the human influence. You may increase the repeatability and the correctness of the results. And you may use these results from the quality control to actually control also the parameters, the settings of the plant. You may use such a control to improve the quality of the product, that's sure. You may reduce the wear of the part and the energy consumption. And you may run a man-less operation. In Austria, we have some plants which already run man-less during the night shifts, more or less, sometimes some completely, some less, but it's still a bigger problem. And the trend goes in this direction, that it runs completely automatic. But we have different systems which are now coming on the market. So first thing is automatic analysis versus automatic sampling and analysis. It's the different thing. We have systems which make a single parameter, like moisture, or we have systems which make multiple parameters. We have methods for physical-mechanical, based on physical-mechanical principles, and we have methods based on spectroscopy. I'll show you some systems which are on the market already available. So there is more than just one. This one, for example, is from the company that makes also the ligno tester. I think ligno tester is quite frequently used here in Spain. This is an automatic system. It takes a sample from the production, measures the durability, and you get the result. The advantage is quite fast. The disadvantage is it's not according to any reference method, and you cannot really integrate it in the process. And it's just one parameter. This is a Swedish system which makes bulk density, moisture, and temperature, so more. It's fully automatic. Output signals may even be integrated in the plant control. It's fast and it's also reliable. The disadvantage is it's a very complex system, and it's still not all parameters which are required. We have spectrometry. This is a nice thing. It's an X-ray system measuring the input in the pellet plant. Usually, I mean, you have got metal separators, you've got stone separators, but this is a system which measures the complete input, 100%. And so you can actually discuss with the suppliers about the cleanness of their material. So you can measure everything which is not wood, for example, which is quite interesting. Usually it's extremely difficult to measure, for example, stones content in wood chips or foreign objects or whatever. These systems can do. They are used like in pulp and paper industry and other industries. It's fast, it's quite expensive, and it's just for the input. But it's there. Other things are near-infrared systems, which are produced by 3 or 4 companies. They come from different fields, and they are, of course, optimized for different subjects. So you can measure moisture extractives, proteins, ash content, and they also claim that you can make density, durability, and other things. They are quite costly, and what I think is their disadvantage is that, especially the durability, is based on integration on indirect parameters. So they cannot measure it directly, so they do a calibration. When you change raw material or when you change production parameters, it's not correct anymore, and you need a recalibration, and it's quite costly. So there is a couple of systems, and they have all got advantages and disadvantages. We have tried to develop a system which is specific for the pellet industry. It took us 3 years to develop this system. It's the only system worldwide which uses the ISO methods inside. We have installed the first one in December last year. It's running since 8 months now without any problems. More than 8,000 measurements already. And we are currently installing two new systems. So what does it do? It actually is 100% automatic. It takes a sample from the production and it measures the durability, the moisture, the bulk density, the temperature, and if you like, also the length distribution of the pellets. It takes a sample from the production, it blows it back, and it sends the results automatically to the control of the pellet plant. So what you can do is, for example, you can use these parameters to control the durability. So you can actually control the additives. or the moisture content of the raw material using this system. So you can really use it for process. That's about the performance of the system. You see, like when we do an international comparison between labs and send out samples, we get the repeatability for bulk density, for example, for 13 kilograms, and for durability 0.2. So it's quite, actually the methods work. But when you look at the standard deviation of these systems, it's more than an order of magnitude better. So the results are much more meaningful, and even small changes are real and not just an error in measurement, which makes it much better to use it for plant control. I think that's kind of the future to go, to integrate such online quality control systems in the production, to optimize the production, to minimize the production costs, and to have a perfect product. I think that's 4.0. And, well, that was my contribution. Thanks a lot.